In this video, we're going to be talking about translations. So how can we translate single points or maybe translate entire figures? We'll do both. A translation is where we can move an object in a direction or for a certain amount of distance. Some people call it shifts. Certainly in higher advanced math, we definitely use the word shift a lot instead of translate. Or in other words, we're just sliding or moving points. So we can either move left, right, or up or down. The way that we know which direction we're moving is we're given some notation. Normally we'll see this as x plus a value and y minus a value, or it could be x minus a value and y plus a value. Those pluses or minuses will change. The a and b will be represented using a number. So we can see an example down here that we're about to do. We'll have x minus a number or y plus a number, for example. The plus or minus, the symbol right there, will tell us what direction to go in. If we're talking about a direction of an x value, that would be moving left or right on the x-axis. And it is just like we would imagine that if we have a negative value here, we're going to move left towards negative values on the x-axis. And if we have a plus or a positive number here, then we're going to be moving right towards positive values on the x-axis. Similarly, for y on the y-axis, if we have plus a number, we're going to move up towards more positive values. And if we have minus or a negative number here, we're going to move down towards the negative values. So let's practice using that. First of all, you want to plot these 3 points. We'll plot A at 2, 2, B at 4, negative 2, and C at 6, 4. We'll be able to connect those 3 points and draw a triangle called triangle ABC. This is our triangle symbol. Looks just like a triangle. That's easy. And we name triangles by using the corner points or the vertex points. So if our triangle is created using points A, B, and C, then we call it triangle ABC. So we plotted ABC here. We connected our points to draw the triangle. Now we're going to move that triangle. And here's how we want to move it. Right here is our symbol to move it. So let's interpret this. This says x minus 6. So I'm going to move left 6 spots. And this says y plus 2, so I'm going to move up 2 spots. If my x value is negative, I go left. If my y value is positive, I'm going up. So we take our points. We can start with A. And we could literally count on a coordinate plane, 6 spots to the left and 2 spots up, and place our new coordinate for A. We can't call it A anymore because you can't be in 2 places at the same time. So we have to label it a different point. So what we do whenever we transform any points or a figure is that we just put a little apostrophe next to that coordinate. So that lets us know that A by itself was the original point, and now A apostrophe, which we call A prime, is the transformed point. It doesn't matter what transformations we do, we always put apostrophes next to a transformed point. So let's do the same thing. We still got points B and C to move. Let's take point B and take it to the left 6 spots and up 2, and label that B prime or B apostrophe. And one more time with C, take it to the left 6 spots and up 2 spots and call that C apostrophe or C prime. So now when we look at these 2 triangles, we can see hopefully that they remained the same shape. They're both triangles. We can also see hopefully that the segment lengths between our points are equal. You could use your distance formula to prove that if you wanted to. I think visualizing it is enough if you believe me on that point. We can see that the areas of the 2 shapes are the same. We could use our area formula for triangles to prove that if we needed to. We can also see that the angles at each vertex, so angle A prime here is equal to angle A here in our original triangle. So all of the vertex angles are the same. And then lastly, what's also true is that the slope between our points is the same or equal. So the slope between A prime and B prime is the same or equal slope as the slope between A and B here. Because all of those things are true, we say that translating or translations preserve the congruence of a shape or figure. The exact same shape, just getting moved around the coordinate plane. If you ever do a problem and you get a shape that looks different or is a different size, then you must have made a mistake when translating, because we shouldn't get that. All right, we're going to do one more. This time, notice that we're going to translate or move our second triangle, triangle ABC prime. So we're going to look at our second triangle here that we moved, and we're going to move that one instead, and we're going to practice it one more time. So you can pause the video and check your work later, or you can just follow along. We want to move it right 4 because we have a positive 4 for the x value. And we're going to move it down 6 because we have a negative value next to our y. So right 4, down 6 is one way we can do it. But I also want to show you how we can use some math here and prove using addition or subtraction without counting necessarily on the coordinate plane, although you feel free to since we got the coordinate plane there. But let's try and do something a second way. So if I take this coordinate of a, which is at negative 4, 4, and I actually just add 4 to my x value, so negative 4 plus 4 would be 0, and my y value is 4. So if I do plug it in here, 4 minus 6, I get negative 2. So I know my new point is 0, negative 2, and that is my new a. We could check it by counting on the coordinate plane. We know we're going right 4 spots, and then down 6 spots, so we end up at the same spot. So again, you can use counting, or you can literally just plug coordinates of your original points into that translated form, and the result will give you your new coordinate for your transform point. Let's try it with b. We could count right 4, and we could go down 6, but let's try and use the math method here. If I take my x value of negative 2 and I add 4 to it, then I get 2, positive 2. If I take my y value of 0 and I subtract 6, I get negative 6. So I should be at 2, negative 6, and that's where I said I would be when I just counted on the graph. One more time, let's do it with c. Taking c prime here. It's at 0, 6. So if I take my x value of 0 and add 4, I get 4. If I take my y value of 6 and I subtract 6, I get 0. So I should be at 4, 0. Well, yeah, if I count over 4 and down 6, I end up at the same spot, 4, 0. Maybe you've also noticed that I added an additional apostrophe here to my points, and that's what we do. Anytime we transform points in sequence, we're going to just add an additional apostrophe. And when you're done, you can kind of see it tell a story. You can see that our pre-image is what our original image is called. That pre-image got moved over here the first time, and then what happened next is that image got moved here to our last final location. So you can follow the apostrophes to see what order your transformations were in. So those apostrophes are important notes. Make sure you use them. All right, just one more thing. Let's see if we can work backwards here. Given a diagram with some transformations on it, can we interpret the transformation? Well, here we're told that we have a translation, so let's see what we did. Again, we're looking for a pre-image. Our pre-image or starting image is the figure that doesn't have apostrophes, just capital letters. The points that have apostrophes show us that that's our transformed or moved figure. So we started with the bottom triangle and moved to the top. You could count, again using that counting method. Let's see how we get from A to A prime. Well, we go left 1, 2, 3, 4, and we go up 1, 2, 3, 4, 5. So it seems like we're going left 4, up 5. So I would write my rule by saying x minus 4 because I go left 4, and y plus 5 because I went up 5. But you always want to check, make sure it's the same for all the other points. We could use a math method, so I'll just show you that as well. If I state the coordinates for b, my original b is at 7, negative 5. And then I want to get to my b prime here at 3, 0. Well, I could write those two coordinates, and then I could just think, how do I get from one value to the other? So I want to get from 7 to 3. I must have to subtract 4 or move left 4 spots. If I want to get from negative 5 to 0, well, I know I need to add 5 or move right 5 spots on a number line. Sorry, that would be up 5 spots since we're on the y value. So if I go left 4 and up 5, in my coordinates, then we could state that as well using our notation. One more time just to check the C. Did it go left 4 spots and up 5? Yeah. Always check all of your points. If any of them are off, well then either you counted wrong and you made a mistake, or those two figures did not get translated. There must have been something else that happened, because otherwise we should have a congruent shape. And so if your points are not using this pattern, then you have slightly a different shape, or maybe you have a completely different shape. So always check all of your points. One more time, you could try it on your own, or just follow along right now. We have our original image, the points with no apostrophes, getting moved to this other image, the points with apostrophes. So there's often common mistakes happening where we flip that, or we're just not being careful enough in our head, and we do it backwards. So if you ever find that your translation is the opposite of what it should have been, you probably started with the translated figure and worked backwards to your pre-image. So just double check that you're starting with points that don't have apostrophes. So I'm going to check D just because that's visually a little easier to look at. C is not too bad, but these points are a little clustered, so I just want something clear to look at. I'm going to state my coordinates for my original D. That's at 3, 6. And I want to get to my D prime here, which is at 2, 3. So how do I get on the x-axis from 3 to 2? I must have moved left 1 or subtracted 1. And on my y-axis, how do I get from 6 to 3? Well, I must have moved down 3 or subtracted 3. So there's my translation. I know I need to do x minus 1 or left 1, and y minus 3 or down 3. So there's how we translate between points or identify translations. Good luck practicing.